imaginary numbers. In order to understand imaginary numbers, we have to remember some of the principles of solving quadratic equations that we learned last semester. Now for this particular example, it's fairly simple. We have x squared equals 9. So essentially what we're trying to do is determine what number do you square to end up with a positive 9. Well, that's just 3. 3 squared equals 9. But if you think carefully, there's another number that you can square that will also give you a positive 9. Negative 3. Negative 3 squared gives you a positive 9. So the answer for x could be a positive 3 or a negative 3. Now, a lot of students, when they solve something like this, x squared equals 9, would just look at it and think, okay, let's just isolate the variable. So to get rid of the square, we take the square root of both sides, and of course the square root of 9 is positive 3 or negative 3. Let's consider a similar example. Here we have x squared equals negative 4. It's the same idea. We want to know what number do you square to end up with negative 4. So you might look at that and think, okay, what about a 2? But actually 2 squared is positive 4, not negative 4, so that doesn't work. All right, so let's think about another number. What could you square to end up with negative 4? Okay, so if positive 2 didn't work, maybe some students would try negative 2. But if you remember negative 2 squared, negative 2 times negative 2 is still a positive 4, not a negative 4. So here we're still looking for a number that you can square to end up with negative 4. That's the big question. So if we can't really come up with the number in our heads, let's go back to the beginning and think like, okay, x squared equals negative 4. To get x by itself, let's just take the square root of both sides. And you might go type this into your calculator, square root of negative 4. If you type that in your calculator, it's going to give you an error message, and it's going to say non-real number. And that's true. There is not a real number that you can square to end up with negative 4. What you do have, an imaginary number is just a number that yields a negative result when squared. Right? The definition you would usually see in a textbook is I equals square root of negative 1. So the imaginary unit I is what you get when you take the square root of a negative number. Now this is very helpful in solving quadratic equations because I want you to imagine squaring both sides of this. When you square a square root, it cancels out. So if I is the square root of negative 1, that means that I squared equals negative 1, which is not an imaginary number at all. So this is the big picture right here. An imaginary number, I, is what you get when you take the square root of a negative. So I equals square root of negative 1. This is important because if you were to square both sides, you end up with I squared equals negative 1. Okay, once we have our mind wrapped around what an imaginary number is, now we can actually do some calculations with it. We know that the square root of 4 is just 2. That's pretty straightforward. So then that means that the square root of negative 4 would be 2i. It's an imaginary 2. You can picture it if you break this down. Negative 4 is just 4 times negative 1. So you could think of this as the square root of 4 times the square root of negative 1. And we know the square root of 4 is 2. And we know the square root of negative 1, that's the definition of I, so we end up with 2i. All right, down below, square root of 121. We know that the square root of 121 is just 11. So that means that the square root of negative 121 is 11i. Again, you can break this down. Negative 121 is just 121 times negative 1. So you can think of this as square root of 121 times the square root of negative 1. And again, you know the square root of 121 is 11. And we know that the square root of negative 1, that's just I. So we end up with 11i. For some slightly more complicated examples, we can look at ones that are not perfect squares. So like square root of 20. I don't know the square root of 20, but I do know that 4 times 5 equals 20. So I can think of this as square root of 4 times square root of 5. And even though I don't know the square root of 20, I do know that the square root of 4 is just 2. So that gives us 2 square root of 5. So likewise, the square root of negative 20 then, your answer would be 2i square root of 5. You can break this down if you'd like. You could think of this as negative 4 times 5, so square root of negative 4 times square root of 5. And then you could even break down the negative 4. Negative 4 is just 4 times negative 1, so you could think of this as square root of 4 times square root of negative 1. And again, you know the square root of 4 is 2. You know the square root of negative 1 is I, and that leaves the square root of 5 left over. That's where the 2i square root of 5 comes from. Let's try one more. Square root of 45. I don't know the square root of 45, but I do know that 9 times 5 is 45, so I can think of this as square root of 9 times square root of 5. And although I don't know the square root of 45, I do know that the square root of 9 is 3. So here my answer would be 3 square root of 5. Similarly, if I did the square root of negative 45, my answer then would be 3i square root of 5. Because you could break down the negative 45, you could think of this as negative 9 times 5. So I can picture this as square root of negative 9 times square root of 5. And then you could even break down the negative 9 and think of this as square root of 9 times square root of negative 1. And again, you know that the square root of 9 is 3. And you know that the square root of negative 1 is I. So that's where you get the 3i square root of 5 from.